This is a problem number 10. This is hard level problem. Here we have to simplify this expression and transform this expression into another equivalent expression which has simple form. Also, we have to define the range or values of variable x where this expression exists. Like us and subscribe, and let's get started. First of all, we have to notice that here we have the power minus 1 over 2. That's why if we denote numerator of our expression as a and denote denominator as b, in this case, since we have negative power, and since we can write that a divided by b to the power minus 1 over 2 is equal to b divided by a to the power 1 over 2. That's why, using this, we first of all have to write that. First, look at this. X must be not equal to 0. So the first, x must be not equal to 0. Second, here, x must be not equal to minus 1. That's why we write x is not equal to minus 1. And third, we have to notice that x, since a numerator here, because of this power, negative power, is a denominator, and here this is equal to 0 when x is equal to 1. So when x is equal to 1, we have 0 denominator. That's why x, we have to claim that x is not equal to 1. So these three values of x we have to avoid, because we want our expression to be meaningful. It must exist. Next, let's rewrite our a. This expression a, or this expression, is in denominator, and let's simplify first of all a. First of all, let's rewrite our a. Let's rewrite this, and we will have x cubed minus 1 divided by x plus 1 times x over x cubed plus 1 is equal. In our beginning of algebra playlist, we actually learned Bezout theorem and how to write shortcut multiplication formulas. If you don't know this, watch my playlist, beginning of algebra, in this channel, Open Math Camp. Here we can write that x cubed minus 1 is equal to x minus 1 multiplied by x squared plus x plus 1. This is a shortcut multiplication formula, because if we talk about Bezout theorem, we know that 1 for this polynomial, when we insert 1, in this case our polynomial is equal to 0. That's why our polynomial is divisible by polynomial of degree 1, x minus 1. This is divisible by this. Watch our video tutorial about this shortcut multiplication formula, because, as I said, it was very important formulas for simplifying algebraic expression. And simplifying algebraic expressions is very important in mathematics. If you solving any math problem, you always will deal with simplifying algebraic expression. So for this expression, we write this. So we write our polynomial of degree 3 as a multiplication of polynomial of degree 1 and polynomial of degree 2. And here, for this polynomial, our discriminant is less than 0. That's why we cannot represent this polynomial as a multiplication of two polynomials of degree 1. That's why let's assume let's assume this polynomial. In this case, it is equal to x to the power 3 plus 1 is equal to x plus 1 times x squared minus x plus 1. This is another shortcut multiplication formula. And in this case, also, for this polynomial of degree 2, we have discriminant less than 0. So we cannot continue our factorization. And if we insert and rewrite our a, it will be equal to x times x minus 1 times x squared plus x plus 1. And in denominator, we will have x plus 1 squared times x squared minus x plus 1. This is a form where we cannot continue our factorization. I'm sure that if we represent our b also in this form, we will have a great cancellations. And that's why let's continue with b, and let's rewrite our b. If we rewrite our b, it will be equal to, b is equal to x plus 1 squared minus x divided by x minus 1 squared plus x times 1 minus 1 divided by x. Here we can, using shortcut multiplication formulas, we can rewrite this numerator and this denominator, and when we do it, we will have x squared plus 2x plus 1 minus x. In denominator, we will have x squared minus 2x plus 1 plus x. And let's rewrite it. Here we will have x in denominator, and in numerator we will have x minus 1 is equal to, here we will have cancellations, not cancellation, but a little bit calculations, and we will have x squared plus x plus 1 times x minus 1 over x squared minus x plus 1 times x. So it was b. Next, let's write b divided by a, and then we will take a square root of this expression. When we write b divided by a, it will be equal to, let's rewrite it again, x minus 1, x squared minus x plus 1 times x, and we divide by a or multiply by x plus 1 squared times x squared minus x plus 1 over x times x minus 1 times x squared plus x plus 1. As I said, here we have a cancellations. This is cancelled by this, and this is cancelled by this. Here we have cancellation of this, and all in all, we will have b divided by a is equal to x plus 1 squared divided by x squared. It means that here we had actually, yes, b divided by a to the power 1 over 2 will be equal to x plus 1, absolute value of x plus 1, divided by absolute value of x. We have this. Now, depending on what is an x, we will have different answers. Let's write it shortly. It will be equal to, and we will have cases. First of all, when x is in a range from minus infinity to minus 1, we will have minus x minus 1 divided by minus x, which is equal to x plus 1 divided by x. Because when x in this range, by definition of absolute value, we will have minus what we have inside absolute value. If you don't know what is absolute value, I'm sure that you know it, but if you don't know, watch our first video tutorial of beginning of algebra playlist. The second case, when x is in a range from minus 1, not including, because as we said earlier, x cannot be equal to minus 1. From minus 1 to 0, not being equal to 0, it will be x plus 1 divided by minus x. Oh, let's write it as this. And second case, And third case, when x is from an interval from 0 to 1, and or from 1 up to plus infinity, it will be everything is positive, and we will have x plus 1 divided by x. So our expression is equal to this, or this expression, depending the value of x. Like us and subscribe, and have a great day. Thank you very much for your time.